Hey everyone, this is our second video covering compositions of functions, but this time from equations. So by the end of this, we'll be able to write compositions using their definitions from the equations rather than the tables that we talked about above. Okay, so I'm going to dive right in. I'm going to use colors again to help me match these. I'm just going to label my functions ahead of time. This one in red and my other one in blue. I like to change the color because it helps me keep track of which is which. Okay. It says, let C be the function that assigns to amount of coffee in liters the milligrams of caffeine in that coffee. Okay, so that's kind of the same setup as before. C is our function. It takes in amount of coffee and gives us milligrams. I'm going to make a little note of this. So C takes in liters and gives us out caffeine. And these notes to ourselves will be really helpful later as we go on to write our compositions. So in blue, something similar. M takes in amount of coffee buys based on the hours he slept. So it takes in hours and gives us liters of coffee. Okay. Now it says, write an expression for C of m of x and interpret its meaning in context. This is pretty straightforward once we get the process. So when we talked about writing these expressions, we found it very useful to start with the outsidemost one. So C of some input, and use that rule. C of some input. C of x said 406 times x. So C of some input is going to be 406 times that input. And we left this space because the next thing we're going to plug in is going to be our m function, but we didn't want to fill it in yet. Alright, so next in blue, our m function, m of some input. M of some input says, m says do negative 2 tenths times, oops, I didn't leave myself enough space. I'm just going to make more space here. Negative 2 tenths of some input minus 9.5. And then I'm going to add a little bracket for our input. So look how the structure of these is the same, right? Inside that input, I'm putting all of the stuff that was in M. So all the blue stuff goes inside the red space. And then finally, I can put the final blank I'm filling in is just an X. X. So altogether, this expression is C first, or then M, then X. So we did C in red, M in blue, and then X is our last input. Now maybe we could rewrite this expression a little bit, just so there's fewer parentheses. 406 times negative 2 over 10 times X minus 9.5. I'm going to take out a couple of these numbers. If I don't like this fraction, let's just handle it. And multiply, it's going to be 812. Negative 812 over 10 times x minus 9.5. And then let's just write that as a decimal. So negative 81.2 times x minus 9.5. We were done at this first step. If you'd written that, you would definitely get full credit. This is just writing it in a way that might be easier to use later on. So write an expression for that and interpret its meaning. So this means C of m of x, we got to say what it takes in and what it puts out. So C of m of x gives the, let's see, what is C output? Because C is coming out of this whole thing. C gives us, let's look back up at our thing, gives caffeine. Okay, so it gives the milligrams of caffeine bought given, so my input is going to be x hours. Let's see, x is what goes into m. Yep, is hours, given x hours of sleep. So as simple as that, it's like what comes out of C, our last function, what's going in, and then just saying that that those are the input and the output. So it says, use the expression you found in A to determine the amount of caffeine Mr. Wade consumes after sleeping for 6.5 hours. Okay, so I know this is a time, this is my input, so X is going to be 6.5. And we're trying to find the output, so let's just use our function. Well, C of M of 6.5 is negative 81.2 times 6.5 minus 9.5. I'm just going to highlight where I put the input. There's my input. I use this simplified version because it's a little easier to evaluate. Could have definitely plugged it into the earlier version as well. But if I evaluate this, I get negative 81.2 times negative 3, I believe. And I don't have a calculator with me. So 6, 3, 24. 3 times 3 is 24. Yep. And there's a decimal. So it's 243.6 milligrams caffeine. Awesome. If we look back to the table, what did we say it was? So 6.5 hours, we're getting 243. So let's look in our table and see if this matches. 6.5 hours. Oh, okay. So it's going to be about 0.6 liters of coffee. 0.6 liters of coffee is somewhere in here. Yep, 240 sounds about right. So that was nice that we could check it in the table, even if we couldn't find it before. So that's what we need to be able to do here is write the composition and then evaluate it, or just plug in a value, just like we did with the table, except this time with our expressions. So again, there's a practice problem below. It gives us the two equations. It says write an expression that is going to give you certain values, so we got to come up with our composition. And then it says use that expression to find a specific value. Alright, so again, try this out, and then check your answers on the answer key just below this video.